So Chapter 10, Practice Test. Two students worked together to solve a system of equations which had integer solutions. Tara made a table of values for the first equation, and George made a table of values for the second equation. Using the students' results to determine the solution to the system, the value of x plus y would equal what? So I need to graph Tara's and George's solutions. So if I go through to do that, I've got Tara's -2 and -6, up to 4 and 6. So there's Tara's line. And I would want to use a ruler to join this, guys. I don't want to depend on trying to freehand it. George, -3 and -2, up to 5 and 6. So the solution is right here. It has integer solutions, so I know that it has to be right on this line. What are the coordinates of this point? 3 over 4 up. So x is 3, y is 4. What's 3 plus 4? 7. My answer becomes 7. Okay, question number 1. The ordered pair which satisfies the following system of equations is what? So I can graph these, I can solve them by elimination or by substitution, whichever you find easiest. If I look at this, x plus 4y equals -13, minus x minus 3y equals 8. I get x minus x is 0, so that's gone. 4 minus -3 is 7. And -13 minus 8 is -21. So I get y equals -3. C has to be the choice because it's the only one that has y equals -3. I could check it by substituting the -3 back in. And I get x minus 12 equals -13. Add 12 to each side, and I get -1. Question number 2. The number of solutions to the following system of equation is. What helps me determine the number of solutions? The slopes, okay? So if I find the slope of each line, for this first one, I'm going to interchange the 24 and the 2y to make the -2y positive. Divide by 2, I get 3x minus 12 equals y. In this equation here, divide everything by 5, and I get 3x minus 64 over 5. My slopes are equal, which means my lines are parallel. So I have parallel lines, which means there would be no solution. Because the intercepts are different. -64 over 5 is not the same as -12.
No way to get 2, is it?
Not with straight lines, no.
So that means that you can take that one out, right?
Exactly. Alyssa graphs the equations x minus y equals -4 and x plus 2y equals 4. The y coordinate to the nearest point of the point of intersection. If you see something that says nearest hundredth, chances are it is going to be a decimal of some sort. So I could graph this, put it into my graphing calculator. If I did that with this first equation, I would interchange the -y and the -4. And I would rewrite it as x plus 4 equals y. And then this equation, I would move my x over, and I would get -x plus 4. Divide by 2, and I get -1/2 x plus 2. I'd put those two equations into my graphing calculator, intersection feature, and then I would solve, and for y I would get 2.6 repeating, which becomes 2.67. I could also subtract the two equations. X plus 2y equals 4 minus x minus y equals negative 4, which would give me 3y equals 8. Divide by 3, and 8 divided by 3 is 2.6 repeating. So either method still would have worked. Question number 3, consider the following two systems of equations. Solve the above systems of equations using a graphing calculator and determine which of the following statements is true. So with this one, it's already written in that y equals form, so I could put that into the calculator and I could find the solution. And in this first one, the solution is negative 18 and negative 11. For these equations here, I have to isolate the y. So I have to move the x over, making it negative, and then divide by 5, and I get negative 4/5 x plus 18/5. This one would be 3y equals negative 2x plus 1. Divide by 3, and I get negative 2/3 x plus 1/3. And the solution to that one is 24.5 and negative 16. So in system 1, x plus y equals 29. False, because this equals negative 29. In system B, x plus y equals 40.5. This will be false because this is a negative, so it's going to make my sum smaller. One of the values is 42.5 more than the other. Or sorry, one of the values of x is 42.5 more than the other. So what is the difference between negative 18 and 24.5? 24.5 minus negative 18 equals 42.5. If I try doing the same thing with the y's, negative 11 minus negative 16, I get 5. So the y values aren't separated by 42.5, it's the x values that are. Question number 4, the system y equals 4x minus 8 and x equals by plus c has an infinite number of solutions if. When do I have an infinite number of solutions to a system? When they're the same equation. So what do I have to do with this equation?
B has to equal 4.
Does b have to equal 4? Look very carefully. How's the equation written, Jonathan?
Oh, x.
So what do I need to do first? I have to solve for y. So I need to move that c over, which would make it negative, and then I need to divide by b. So I get 1 over b times x minus c over b equals y. Now 1 over b has to be equal to 4. So I get 4 over 1. I cross multiply, and I get 4b equals 1. B equals 1/4. So that eliminates C and D. And then my negative C over B has to be equal to negative 8. Right? I already know what B is. B is now negative 1/4. So I get C over 1/4 equals negative 8. Cross multiply, and I'm going to get negative c equals negative 2. So positive c will equal positive 2. And I get B for my answer. Because in this step right here, if I just cross multiply, I'd multiply 1/4 times -8. Question number 5. The graphs of y equals ax plus b and y equals cx plus d are parallel. So the number of solutions to this system is what? Parallel lines have how many solutions? 0. They're parallel to each other, so they're never going to intersect. If I draw a picture of it, there's parallel lines. For which system of equations graphed on a grid is the point -2 and -1 a solution? How would I solve this? Substitution. So if I look at this first one, I get -2 minus -2 times 1 is +2, which gives me 0. That doesn't give me 3. So this one doesn't work. If I look at B, 3 times -2 minus 3 times -1. 3 times -2 is -6. -3 times -1 is +3. So I get -3 for an answer. Doesn't work. So now I'm on C. 2 times -2 minus 10 times -1. This becomes -4 plus 10, which is 6. So it worked for the first equation. I need to check the second equation. -2 plus 5 times -1. I get -2 plus -5 is -7. So C ended up not working. And as long as I'm positive about my math, I could then pick D by default. I could check D very quickly. -2 plus -1 does equal -3. -2 times -2 becomes 4. 5 times -1 becomes -5, which equals -1. Question number 7. When solving a system of equations, one of which is x over 4 minus y over 3 equals 2, a substitution that can be made. So a substitution that can be made, they have x by itself. So I would have to move the y to the other side. And then how do I get rid of this 4? I have to multiply by 4. So if I multiply by 4, I get 4y over 3 plus 1/2. Doesn't that get nice and messed up? Oh, right, yeah, sorry. So how does that help me? Is there any that I can eliminate?
You could just write it as 1/3 and then multiply the 8 by 3 and the y by 3 and then put it into brackets, like how they have it there.
Mm-hmm. If I take out a 1/3. If I take out a 1/3 from here, 4/3 divided by 1/3 gives me 4. And 8 divided by 1/3 gives me 24. And D becomes my answer. C and A I should be able to eliminate because I'm not dividing by 4, I'm dividing by 3. And then with B and C, what I could do is I could multiply this through, and I get 4/3 y plus 2 and 4/3 y plus 8 if I expand those two out. Question number 8. In solving the system, 3a minus 2b equals 14 and 2a plus b equals 7 by elimination, an equation which arises could be. So I have to actually check both of them because I do have somewhere it's a b equals and an a equals. So let's say I tried to get rid of, I'm going to try getting rid of the b. Because if I get rid of the b, I just have to multiply this one by 2. So I get 4a plus 2b equals 14, and 3a minus 2b equals 14. I would add them together, and I would have 7a's equals 28, which becomes d. If I had tried to eliminate the a's, I would have had to multiply both equations by a factor. If x plus y equals 12 and x minus y equals 2, then what is x plus 2y? So what I need to do with that one is I need to solve for x and y. And I can do that by elimination because I can add these together. The y's would be eliminated. 2x equals 14. X equals 7. 7 plus y equals 12, so y equals 5. So now I have 7 plus 2 times 5 equals 17. Okay? I'm going to give you a minute. I want you to work on question number 10 because I just need to answer a separate question. Okay. To go through this one, I need to remove brackets and collect like terms. So I would get 3x plus y equals 13 because this negative, I'd get a negative 6, which I'd move to the other side. And then I would get 4x minus 3y equals 13. Because I'd get this positive 3, which when I move to the other side would be negative. How you decide to solve this, you could use substitution, you could use elimination. If I was going to use elimination, they want the y, so I would have to eliminate the x's. So if I eliminated the x's, I could use substitution. Or would substitution work? Nope. Now if I use substitution, I would get y equals, I get an x equals equation, I want a y equals equation. So to get rid of the x's so that I get a y equals, I'd multiply this first equation by 4. 13 times 4 is 52. And I'd multiply this equation by 3. And I would get 12x minus 9y equals 39. And then I would subtract. So 12x minus 12x is 0. 4 minus negative 9 is 13. 52 minus 39 is 13. And y equals 1. Question number 11. Solve the following system using elimination. Before you try to do this, you need to get rid of those fractions. So what can I multiply the 3, the 4, and the 2 by? What's my common factor between those three? Or common multiple, sorry. 12. So if I multiply the first term by 12, 12 divided by 3 will give me 4, and I will get 4 times 2p. 12 divided by 4 is 3. So 3 times 3 cubed. 12 divided by 2 is 6. 6 times 11. So I get 8p minus 9q equals 66. What can I multiply the second equation by? Common multiple for 9 and 6, 18. So I get 18 divided by 18 divided by 9, which is 2, and 2 times 5p would be 10p. 18 divided by 6, so plus 3q. And then 18 times 3 is 54. If I multiply this equation by 3, my q's would end up both equaling 9. So I'd have 30p plus 9q equals 154 times 3 is, what's 154 times 3? $162?
Yep.
And then 8p minus 9q equals 66. Add them together, and 38p equals 228. And what is 228 divided by 38?
6.
And A is my answer. If m minus 2n equals 30 and m minus n minus 39 equals 0, then the value of m minus n is. So what that means, m minus 2n minus 30 equals 0, and this also equals 0. So I could multiply the first equation by 2. 2m minus 4n minus 60. Actually make it equal 60. And then I would leave, sure what the line there yet. Leave that equation as 2m minus n equals 39. And I would subtract them, because 2m minus 2m equals 0. Negative 4 minus negative 1 equals negative 3. And 60 minus 39. So n would equal negative 7. Plug it into one of those two questions. M minus 2 times negative 7 equals 30. And I get m plus 14 equals 30, so m would equal 16. And 16 minus negative 7 equals 23. Question number 12. I'm getting there. If 2x plus y over 3 minus 5 equals 0 and 3x minus y over 5 equals 1, then the value of y equals. So what I would do first of all, let this equal 5. Move the negative over. Then if I multiply by 3, I get 2x plus y equals 15. And if I multiply this by 5, I get 3x minus y equals 5. Add the two equations, and I get 5x equals 20. So x equals 4. A is not the answer, because this is what x equals. Then I can solve for y, and I can use either equation. 2 times 4 plus y divided by 3 equals 5. So 8 plus y equals 15, and y equals 7.
Question.
response. The straight line ax plus y equals b passes through the points -1 and 1 and -5 and 4. What's the value of a and b? If I substitute this point into this equation, I get -a plus 1 equals b. -1a plus 1 equals b. If I do the same thing with the -5 and 4, I get -5a plus 4 equals b. So if I multiply this system by 5, I would get -5a plus 5 equals 5b. If I subtract, I get -5 minus -5 is 0. 4 minus 5 is -1. B minus -5b is a -4b. So I get that b equals 1/4. And then I can substitute it back into one of the two equations. I can put it into this equation. -a plus 1 equals 1/4. Subtract by 1 on each side. 1/4 minus 1 is -3/4. So if -a equals -3/4, positive a equals +3/4. So then when I go to multiply these, 3/4 times 1/4 is 3/16, which as a decimal is 0.1875. So to the nearest hundredth becomes 19 hundredths. And yes, I know I'm going through these fast. Lisbeth cycles 100 kilometers from Calgary to Canmore. On the uphill section, her average speed was 12 kilometers, and on the rest of the trip, her average speed was 28 kilometers per hour. She cycled for a total of 5 hours. If x represents the distance traveled uphill and y represents the distance traveled on the rest of the trip, which of the following systems could be used to calculate the values of x and y? This is your distance, speed, and time charts. So you want to draw this out. Distance, speed, and time. And we have the two sections. We have uphill and we have the rest. I'm told that x is the distance traveled uphill, y is the distance traveled on the rest of the trip. Uphill, her speed is 12 kilometers per hour. The rest of the trip, her speed is 28. Okay? Things that I know. The distance to Canmore from Calgary is 100 kilometers. So her distance up and the rest is going to equal 100. X plus y will equal 100. So that equation is right, and that equation is right. In my triangle of D, S, and T, if I cover up T, it's distance divided by speed. So this is going to be x over 12 and y over 28. Her time was 5 hours. So her time is x over 12 plus y over 28 equals 5. B becomes my equations. That's my system of equations that I would solve. If I went to solve this system, what I want is I want to get rid of my fractions here. So I want a common denominator for 12 and 28, which is 84. 84 divided by 12 is 7. 84 divided by 28 is 3. And 5 times 84 is 420. So then if I took this equation and multiplied it by 3, I would get 3x plus 3y equals 300. Subtract, and 4x equals 120. and x equals 30. So that's 30 kilometers uphill and 70 kilometers the rest of the way. So 30 kilometers uphill. Two more questions. Susan solves the system of equations 2 over x plus 3 over y equals 2 and 8 over x minus 9 over y equals 1. By first substituting a for 1 over x and b for 1 over y, what's the value of x and y? So if I substitute a for 1 over x, what I get is the equation 2a. And if I substitute 1 over y, if I substitute b in for that, I get 3b. And then I don't have these fractions of x's and y's to deal with. And then I get an 8a minus 9b equals 1. So if I multiplied this equation by 3, I would get 6a plus 9b equals 6. So multiply that by 3. I can add the two equations together, and I would get 14a equals 7, and a equals 7 over 14, or a equals 1/2. So what that means is 1/2, that's what I get for a, equals 1 over x. If I cross multiply, I get 1 times x is x, 2 times 1 is 2. So my value of x is 2. If I substitute 1/2 into this equation, 2 times 1/2 plus 3b equals 2. I get 1 plus 3b equals 2, 3b equals 1, and b equals 1/3. So 1/3 equals 1 over y. And again, I cross multiply, and I get that y equals 3. So the value of x times y, 2 times 3 is 6. These questions are highly algebraic because there's no way of fudging your way through it. You can't graph this. You can't. It becomes very complex to try to solve this by any other way than using the algebra taught. Question 15. Chris walks 8 kilometers per hour and runs 12 kilometers per hour. One day he walks and runs on the way from his house to the library, and it takes him 20 minutes. On his way back, he walks and runs, but he runs twice as far as he did on the way to the library. The journey home takes 17.5 minutes. The distance between his house and the library is what? So, we have from his house to the library, and then we have from the library to his house. We have two different things going on. And this is a distance, speed, and time thing again. So we have distance, and this is walking and running, his speed, and his time. Okay? Chris walks at 8 kilometers per hour and runs at 12. One day he walks and runs on the way from his house to the library, and it takes him 20 minutes. I don't know the distance that he walks and he runs. Those could be my unknowns. So then my time is distance divided by speed. So I get x over 8 and y over 12. And I know that the time he spent walking and running is 20 minutes out of 60. I have to put it over 60 because the speeds are given to me in kilometers per hour. So my time has to be in hours. And then we have the other chart.
Do you mean minutes instead of hours?
20 minutes out of 60 minutes, which then converts this to hours. So this would be a third of an hour. Because this right here is given to me in hours, 8 kilometers per hour. So it's either I have to change the kilometers per hour into kilometers per minute, or I change the time into minutes, or from minutes into hours. So walk and run, distance, speed, and time. So again, walking and running is the same, 8 and 12, guys. Only with this last one, he runs twice as far as he did on the way to the library. So his running time is twice that amount. So then the distance that he walked would be the difference from the first time. So he ran twice as far this time, which means I'd have to take this distance away from my walking speed, or from my walking distance. And then this would be 8 over x minus y, and 12 over 2y, which then becomes 6 over y. So in this equation, I would have 8 over x minus y. Oh no, I have that backwards. Distance divided by speed. X minus y over 8, and 2y over 12, which would become y over 6. So now I have x minus y over 8 plus y over 6 gives me 17.5 minutes out of 60 minutes. And that's what I would have to solve to get the distance between his house and the library. I'd have to find x and y. So this becomes a very complex question to solve. I won't give you a question this complex on your test. But if we went through and we solved it, my common denominator for the first one is 120. 120 divided by 8 is
15.
Thank you. So I get 15x plus 10y equals 40. And this one is also 120. So I get 15 times x minus y plus 20y equals 2 times 17.5. So I get 15x plus 5y equals 34. And it's 5y because I get negative 15y plus 20. If I combine these two equations and I subtract them, I get 5y equals 14. And y equals 14 divided by 5, which is 2.8 kilometers. Oh, sorry, 16. Okay. So then that would be 5.2 kilometers.
It's not 16.
Did I get it wrong still?
Yeah, it's 6, not 16.
Oh, right. I think I did something wrong because I'm not getting the right answer.
That's because 2 times 17.5 is 35.
There we go.
2 kilometers.
Okay, it should be 35. I'm still recording, guys. So then that would be 5, and this would end up being y equals 1. And then if I put it back into one of these two equations, I would get 15x plus 10 equals 40. 15 x would equal 30, which means x would equal 2. X is walking, y is running, so 2 plus 1 gives me 3 kilometers is the distance between the library and his house.